So once we capture such packets, okay, we can have access to the routing pattern that is used in the network. Okay, so this enables the sniffer to construct a topology of all overhead nodes. You will see that in the tool. And finally, he can use this routing pattern in order to trace a stream of messages back to the source. Because whenever in a sensor network we use multi-hop routing protocol, all of the messages are sent through this protocol. So all of the messages, okay, are carried as a payload of a more generic multi-hop message that is handled by the routing protocol. Okay, so we can trace the stream of messages back to the event. Okay, so by capturing data and extracting information, like we presented in the previous slide, we can launch again a various number of attacks. So the security profile of a wireless network, okay, in the sensor networks, is exactly the same as a wired network. Okay, so we have confidentiality attacks in an attempt to intercept private information sent over the wireless medium, okay, eavesdropping, data replay, selective forwarding. We have integrity attacks, okay, send forged data frames, like program image dissemination, data injection, and malicious code injection, okay, malware injection. And finally, we have availability attacks, okay, try to impede delivery of wireless messages, okay, like sinkhole attack, which is really important, and hello flood attack. Now, all of these attacks are supported by the current version of the tool and will be explained and demonstrated, hopefully, later on. Now, a few words about the deployed toy network I have over here. Okay, it's really simple. Okay, just to try to show you how the attack tool works against such networks. Okay, so the sensor platform that we used, as we said, it's the T-Mode Sky. Okay, this is a picture. I don't know, maybe most probably you don't see it over here, but okay. So these are the characteristics of this platform. It was created by a company named Crossbow, which actually now is closed and renamed herself to Scintilla. The most important thing that you have to keep in mind for later on when we talk about code injection attacks is that T-Mode uses the MSP430 microcontroller, okay, which is based on the von Neumann architecture. Okay. Von Neumann architectures, memory and data and memory and program memories share the same address space. Okay. So you can actually move the program counter and execute codes that are stored in the data memory. Okay, this is important. Now, the program, the stored applications that I have on these sensor nodes, okay, again, are really simple, but are widely used in universities for research. But they are very simple. The first one is called Delta, and it's actually a multi-hop data collection applications. Okay, devices sample their internal temperature sensor and set back the reading to the base station, okay, through a multi-hop routing path. We have the oscilloscope application, which is actually similar to the Delta, but the difference is that it senses all of the sensor on the T-Mode Sky. Okay. We have, as you can see, 7 channels for monitoring humidity, moisture, voltage, and all this stuff. And then it collects 10 channel readings and again broadcasts them to the base station. And finally, we have some exploits for demonstrating malware injection. Okay. Again, these are simple applications which intentionally have a vulnerability, okay, in order to be able to do an overflow to show the code injection. Okay, so now this was the theory, it was the boring stuff. Let's move to the interesting part, which are the attacks. Okay, let's first of all, what motivated us to build such a tool? Okay. By compromising the sensor network security, our goal was to reveal all the wireless networking vulnerabilities for this kind of networks. Okay, because nowadays, when they all try to find the killer application for these networks in order to be able to sell them, but less of people work with the security stuff for this kind of networks. So, and also we wish to describe even better ways to perform existing attacks for attacking the underlying protocols, and also study their effects, okay, and demonstrate them in practice, how they are operating. And also this is a good way for an attacker that comes up with novel attacks to try and test their effectiveness against real networks. So generally, by publishing such a tool, we wish to shed light on the weaknesses of all the protocols that are widely used in the research community. So we think that by highlighting the need to come up with more efficient security protocols, we will actually motivate the researchers to start actually implementing them. And one more thing, because it's fun, and you can do it, and especially when you go to conferences and places where you see people with sensor networks trying to demonstrate their own killer application. And if you ask them that is it secure, they all say yep, and then you do the attacks and everything falls apart. So here, you can see the architectural layout of the attack tool. So it uses an intelligent component-based system. The hostage component, as you can see, is the network sniffer for passive monitoring and logging of all radio packets. So traffic analysis or any packet decoding can be done either in real time, where you overhear the messages, or offline through the implemented packet description database that we have in the network sniffer. We have the network attack tool component, which is the main component of the tool and provides a number of actions for compromising the sensor network security profile. And finally, we have the network visualization component, which is actually the GUI of the tool, for displaying the overhead network topology, all of the messages that are captured by the sniffer, node states, and status of any attacks that take place and are in progress from an attacker. Now let's start with the network sniffer. It relies on transmission that comes within the range of the antenna or the sensor hardware that is attached to the tool. So conceptually, it consists of the local packet monitoring module, which is responsible for gathering all audit data to be forwarded over the serial port to the packet storage module for logging of the messages to the attached host. So this let us for offline analysis of all the packets that are captured by the tool. Now, let's talk a little about the audit data. So audit data are again actually all the transmissions that come from all the nodes that can be overheard by the antenna that we use with our tool. So this can be collected by listening promiscuously to all neighboring nodes' transmissions. What promiscuously means is that once a node is in our range, we capture his transmission independent of the destination ID or the message type. Whatever he sends or he receives, we capture it and we log it. So once a packet is captured by the sniffer, also we put a timestamp, in order to be able to give the possibility to the attacker to do some time-based analysis after that. And now, when the sniffer has a packet, what we need is a smart way of trying to decode this packet, either if they are encrypted or not. That's why what we have done, we have created a packet description database which contains annotated message structures for the most widely used application messages and underlying protocols. So in that case, the packet decoder can use all of this message structure in order to decode the overhead packet payload. And it gives access to the attacker to the actual fields of the packet. But even in the case that we receive a message that we don't know the structure, we haven't installed it in our packet description database, again we capture it, we log it, but since we don't know the structure of the message, we just give access to the attacker to the payload, to the byte representation of the payload. But again, the attacker can actually change the payload, change the bytes, and again retransmit it. So whatever kind of message is sent through a network, we can capture it. So this is important because, there are some really well-known network applications, so we know their messages and the underlying protocols, so we can put them inside the packet description database, but we don't know everything. So whenever we go to a network, we wish to have access to the data transferred within. So the configuration of this packet description database, okay, it's really simple, it's extendable. So anyone that takes the tool and takes the source code